Welcome to January 21st LeetCode Challenge. Gas station. There are n gas stations along a circular route where the amount of gas is the ith station at gas at index I. You have a car with unlimited gas tank and a cost at index I, amount of gas to travel from I station to its next I plus 1 station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index. You can travel around the circuit once in a clockwise direction. Otherwise return -1. If there exists a solution, it's guaranteed to be unique. Alright, that means we're guaranteed to have a unique answer. We start off with an empty gas tank. We're given the integer array gas and integer array cost. And we need to pick up an index where we can start in order, if it's possible, to do a clockwise direction to reach all of the stations, right? All of the circuit. So since the output here is 3, so we start off at index 3, right? Which is right over here. So at this location, we pick up 4 units of gas, as stated here. That means that we move all the way to unit 5, where we have to expend 1 unit of gas. So we pick up 4, we minus 1, and then we pick up 5 units of gas at station number 4. So therefore we have 8 units of gas. So at station 4, or the index 4, I should say, we go all the way to the beginning, which is 1. We have 8 amounts of gas, we spend 2, but we pick up one unit of gas there, so therefore we have 7 left. From index 0, we go to gas station number index 1, where we spend 3 units of gas, which is 7 minus 3, but we also pick up 2 units of gas, so therefore we have 6. And then we go to index 2, where we spend 4 units of gas, so we have 6 minus 4, but we pick up 3 units of gas, therefore it equals to 5. And then we have to go through station, so therefore the cost is the travel station 3 is 5 units of gas, so we have enough gas to travel back to station 3, which was where we started off. Therefore, return 3 is the starting point, right? That's pretty much the concept behind this example and this question. However, if given the integer array gas and cost, if we cannot make a round trip or clockwise around the circuit, then we return -1. Because no matter where we start, at index 0 or index 1, it's going to cost more to spend the amount of gas we have, because you see it's pretty obvious that 3 is bigger than 2, therefore we can't stop at index 0. 4 is bigger than 3, we can't start up at index 1 either, so because there's not enough gas. If we start up at index 4, and we pick up 4 units of gas, and we spend 3 units of gas, as we move on to gas station 2, we pick up 2, and then we pick up, we have the cost, we pick up 2 units of gas, and we spend 3. Therefore, we're going to have 4 units of gas, but we have to minus 3 here. And then we move here. So therefore, we're going to have 3, we're going to pick up, basically, we have 3 units of gas left. Therefore, we spend 3 units of gas, picking up 3 units of gas. Therefore, we equal to 3 again. But we can't travel back to, what's called index 2, station 2, because it requires 4 units of gas to leave station number 1. And that's pretty much it. We return -1 because we can't complete the circuit. Constraints: length of gas equal to n, length of cost equal to n is between 1 to 10 to the 5. Gas at index I and cost at index I is between 0 to 10 to the 4. Alright then, so from what I understand so far, it's kind of hinting that we do some kind of a greedy approach algorithm. So pretty much right away we can roll off how to get -1, right? Basically, if the sum of gas is less than the sum of the cost, therefore we cannot return, we have to return -1. That's just basically saying that all the gas in the gas integer array, the sum of that is less than the sum of all the costs of the gas. That means it's impossible to even make the trip to begin with because there's no amount of gas enough to fuel the costs. Now that's the quick way we could just eliminate and get -1. There's a proof for it as well, but it is that. So we are going to define a couple of variables called so we need to know whether at station, whatever index we're at, can we make it to the next station, right? And in order to do that, we need to be able to do like a for. We need to be able to iterate through each of these indexes and find whether we can make it all the way to the end. So we need to basically construct a for loop with kind of an if statement inside to know whether we can reach our destination or not, and which index we should reach off our destination at. And we're going to apply the greedy approach algorithm to this. And it starts off with identifying the start index, so we'll call it index, or output actually. Index is fine, which is the index where we start off. Initialize to 0, and we are going to define if we could define a variable where we would basically take the gas at index I minus the cost at index I, whether we travel there or not. So whether this distance that we could travel, so can travel or can reach. Is there a word in here that we could use to help us? Travel, or right, can travel. And that's equal to 0 in the beginning. So we have an index where we can keep, this is the one we want to return. The return and output, which is the index where we travel the circuit at least once in clockwise direction. That's this number right here. And then this can travel, meaning it's the value whether we take an index I at gas and minus the cost. If we could do that, that means we could travel to that index. Alright, and that's pretty much just iterate through for I in the range of the length of gas or cost, doesn't matter, because they're both the same. If you can travel, we want to be able to find the amount of can travel. Actually, I'm going to name this to fuel tank. Fuel, because it's technically the fuel that we have, right? We start off with 0 fuel. This is a lot better. And then in order to calculate the fuel, you need to find the gas minus the cost. Gas at index I minus the cost at index I. And that's the fuel we have. Alright. So now that we know the fuel, if the fuel is less than 0, that means we cannot reach it, right? So if fuel is less than 0, then we would have to set fuel equal to 0. So if fuel is less than 0 here, that means the gas at that index, meaning we cannot travel this index at all. However, right, so set that equal to 0, and then we want to go to the next index until we have enough fuel to travel to the next location. So therefore we increment index by I plus 1. Like that. Return index. So this is assuming that, yeah, let's run this code and see if this works. Okay, accepted, nice. So basically, the little end there, so if this index I does not work, and the field is less than 0, that means we have to move to the next index and see if it works, right? And then if it works, and we keep on iterating through the fuel at each if the index, if we could go around and reach all the index of the length of gas, then we know that we have made it to the end, and therefore we can return the index that it satisfies the behavior that we're looking for. With the index, you can travel around the circle. So this is using the single pass greedy approach algorithm. Let's see, time complexity is big O of n because we have a for loop right here. Space complexity is big O of constant space because we store everything inside a single integer variable. All right, that's it, guys. Have a great day.